Hey Royals, in today's lesson we're going to define the difference between a scalar and a vector. And we're also going to discuss how do we represent vectors in physics or in mathematics. Okay, so let's start with what the heck scalars are versus vectors. Well, scalars are quantities that we measure that only have a magnitude. And I'll give you a couple examples of them. So I might say time. Time has a size to it. So I might say 60 seconds or 3 hours. Age, you could say that someone's 16 years old or they're 53 years old, right? I might say speed. Speed is a scalar because I might say that I'm moving at 30 meters a second, or I might be moving at 100 kilometers an hour. Now, notice that all of these objects, or these quantities I've just defined, only have a magnitude to them. There was no direction associated with them. So a scalar is a quantity that only has a magnitude with it. Now a vector, on the other hand, is something that will have both a magnitude and a direction. So an example of that might be, velocity. So I might have said that I was moving at 100 kilometers an hour, but the minute I say that I'm moving at 100 kilometers an hour north, I've now associated a direction with it, which makes it a vector. Okay. Another example of that might be displacement. Now, displacement is a measure of how far away I am from a specific position in space. Okay, so I might say that I am 5 meters west of my front porch, or I might say that I'm 2 meters left of the classroom door. These are all quantities that are vectors because they have a reference point. In the first example, when I said towards the front porch, that was my reference point. Or in the classroom sitting, I might be 2 meters left of the door. So that I have a reference point, and that gives me a direction associated with it. Okay, and another example of it might be weight. Weight, a lot of people think, wait a second there, that's just how much I weigh. No, weight is actually a force. So a force is a quantity that has a magnitude and a direction. So your mass, how much material you're made up of, is attracted to Earth's surface by the acceleration due to gravity, and that makes up a force known as the force of gravity. And this force has a direction, and it's towards the center of Earth. And that's what we associated with the word weight. Okay, so it is a quantity that has both a magnitude and a direction. Okay, so we now know the difference between a scalar and a vector. Let's figure out how I can give the notation for a vector. Now, vectors have the notation that it's a variable with a little arrow above it. So I would say a variable with an arrow above it. So an example here, i.e., I could write A with a little arrow above it. That to me means that it's a vector. It's a variable, A, that is also a vector. Okay? How do I define its size? How big it is? Well, I might say A with absolute bars around it. So the absolute bars knock off that direction. I don't care what direction it is. I'm just talking about how large it is. So I might say, i.e., A is 5 kilometers in size. It's a vector that is length 5 kilometers. How do I talk about the direction then? We place the direction in square brackets. So direction is placed in square brackets. So if I wanted to talk about the north direction, I would say N and put it inside a square bracket. So that means north. What if I wanted to say forward? I might write it FWD just as a short form, and that means forward. Okay? Visually, now what does a vector look like? Well, visually, it is a vector. It's a arrow. So visually, this is what it looks like. I might say that this is the vector, this is the vector A, which has a magnitude of, say, 5 kilometers. and it is direction, we got to put a direction on this. Let's say that this is 10 degrees. I'm going to say that's east, 10 degrees towards the south, because I start in the east direction and I move towards the south. Okay, so what other parts of this vector are important to us? Well, the point where that arrowhead is called the head of the vector. Now, the part that doesn't have the arrow or the point on it is called the tail. Okay, so we always have our vectors positioned so that at the reference point, we have its tail and the vector point comes out of that reference point. All right, so let's go ahead and draw a vector. Draw the vector A, which we're going to say, actually, I'm going to call it D. Let's call it D just as something different. And we'll say that's 5 kilometers. And in this case, we're going to go north 30 degrees west. Okay, so I'm going to go ahead and try to draw this vector. So I'm going to draw my axis. Oops, I wanted it to be straight. I'm going to draw an axis here. And I'm going to define upwards on my page as the north direction. And I'm going to draw my vector. So my vector starts in the north direction and it's going to rotate. So I'm going to start it pointing north and I'm going to take it and I'm going to rotate it 30 degrees towards the west. So this rotation here was 30 degrees. Okay, so that vector I just drew, and let's see if I can get the arrowhead on it. So this vector here is my vector D, and I could call it D is 5 kilometers, and I'm going to throw the magnitude on it, and therefore the length of that arrow is 5 kilometers. Now, one way that I wrote it was 5 kilometers north 30 degrees west. Now, this vector is from space, so that means I could have started pointing in a different direction and rotated to get there. And what I mean by that, let's see what I mean by that. Let's say I started pointing south. So I could rotate south and come this way by 150 degrees, right? So I could have said D is also equivalent to 5 kilometers south, 150 degrees west. I could have rotated in that direction. I could also rotate this way and say that that is 90 plus 30 gives me 120. And I could say D is also 5 kilometers. That's the length of it. And I could go east 120 degrees north, which means that I start pointing in the east direction and I rotate towards the north by 120 degrees. Okay, so hopefully you have a sense of what we mean by a scalar versus a vector, how we can write vectors, and how they can be visualized. So if you have any questions, please don't hesitate to reach out to me.